Welcome to Smart Architectural Programming, your destination for mastering Java the smart way. In this video, we're diving into applying inheritance in Java, companion video for a book Introduction to Java, and this is the second video of chapter number 2. So without further ado, let's push forward and learn about inheritance in Java in more detail. We've covered it superficially in the previous video, but we're going to dive a little bit more deeper in this particular video. So let's talk about inheritance. Inheritance is one of the cornerstones of object-oriented programming in Java. It allows us to create a new class based on an existing class, promoting code reuse and logical class hierarchies. So first of all, the first aspect you need to understand in inheritance is the usage of the extend keyword. Let's start with extend keyword. This is how Java lets one class inherit from the other. Think of it as saying class P is a specialized version of class A. So if you can see the screen here, let me use some pen here to, explain this further. So you have an animal class, which is basically the main class that you defined. And dog, it's a type of an animal, right? If you want to define a class of dog, you would particularly want to take some of the features out of the animal class. So you extend the animal class and write a class called dog, right? What this basically means is animal is a generalized class, while dog is a more specialized form of the animal class that we defined here. Here, dog extends animal. This means dog inherits all accessible members of animal. Like the make sound method, we can now create a dog object and call both make sound and bark, right? So it seems simple enough, right? So we have a sound of an animal which is generic, right? Some generic animal sound as we print that when we call this method. But we have another method in the dog class which says woof, as you can see here. So what happens here is the dog class can use the both woof and some generic animal sound methods when we call upon them, because it inherits all the methods of the animal class and just specializes some of them for the dog class. With that understanding, let's understand what overriding methods in a subclass is in inheritance. So sometimes the inherited behavior isn't quite right. We need to tweak it to make it more relevant to what we need, right? And that we can do using the override method, override descriptor here, as you can see. So this particular syntax here is necessary for us to override certain actions of the extended specialized class to make it more different, right? So by using this override annotation, we're telling Java that we want to provide a new version of the make sound method, specifically for dog. So we're trying to override the existing method that we defined in animal within the specialized class of dog and telling that we want a specific niche or new behavior of this method from the animal class when we're talking about the dog class or working with the dog class. And instead of, as you can see, make sound of some generic animal, we are using bark here to make that adjustment. So before we move further, a very important tip at this point. You need to always use override to catch mistakes like mismatched method signatures. This is very, very essential if you want to get good and don't want to make any major mistakes while you're coding or working with inheritance in Java. So next thing we need to understand is the implements keyword, right? So Java doesn't support multiple inheritance through classes, but it does allow it through interfaces. That's where implements keyword comes in, basically. What do we mean by that? Here, as you can see the car class implements the movable interface, which means it must provide a definition for the move method, basically. So the car class, we have created an interface with movable called move, right? What it means is that any car class that's using the move method must provide a definition for the move method itself. As you can see, move method is defined here. It's implementing movable. So keep that in mind, and it's a useful thing to keep note of. It's not that very essential right now, but having an understanding of what it is something that you need to keep in your head as you move along in this course. Then we have implementing multiple interfaces at the same time. We talk about single interface. Here we're implementing multiple interfaces. So we have flyable, shootable interfaces, and they have methods fly and shoot. So when we define the class jet, which implements flyable and shootable interfaces, you need to understand that it must implement the fly and the shoot function. So first it defines the fly function for itself, and then that just prints jet is flying, and then it defines the shoot function for itself, which is saying jet is shooting. So these are the two important aspects to keep in mind when you're implementing multiple interfaces, rather any interfaces. So the jet class implements both flyable and shootable. This is a very important and powerful way to design classes with multiple capabilities. So simply speaking, interfaces allow multiple inheritance, and you must implement all methods from each interface for it to work. So I think that part is covered here. If you want to take a quick uptick of that knowledge that I just talked about in the previous slide, it's covered here basically. Implementing flyable and shootable, and how when you're using interfaces, you must allow for multiple inheritance, and you must implement all methods from each interface. That's a quick uptick on this video, so keep that in mind. So with that out of the way, we need to understand why we need to use inheritance. Let's take a step back. Why does inheritance matter? It promotes cleaner code, reduces duplication, and improves maintainability. Imagine a program with animal, dog, cat, and bird. Using inheritance, you write common behavior in animal, then let each subclass provide its unique features. So that's a simple thing of why you need to use inheritance. And I'm not going too deep into that because I've covered the advantages and the constraints of inheritance in the previous video. If you missed that, please go back there and read that video, because it provides an important base for further understanding of this video, where I'm going over relatively higher level concepts and going over them quickly, because I think to a large degree I've covered the basics of inheritance, the very foundational elements of inheritance in the previous video. So to have a quick recap, we understood how we need to use the extend keyword for class inheritance, how we need to override methods with the override keyword, how we need to use the implements keyword for interfaces, and how we implement multiple interfaces for flexibility. Mastering inheritance locks the true power of Java's object-oriented features. For more detailed examples and hand-on practice, check out our Introduction to Java book by Smart Architect Programming, which contains a lot of exercises and projects that you can do to further your understanding of inheritance. Don't forget to like, subscribe, and turn on the notifications. Up next, polymorphism in practice. Thanks for watching, and code smart.